Hello, in this video we're going to go over Mach4 GUI.exe. This is the screen editor version of the screen interface. We'll double click it here. You could select your profile, you can create a profile, copy a profile, restore a backup, and delete a profile. We're just going to go in and run Mach4 test. And as you see, it pops up blank. There's a little progress dialog, and it's putting the screen components together as it's loading. One of the things we're going to go over first, before we even go into screen editing or anything, I had mentioned a little bit earlier about a logging facility that was in that we may ask you to do. And under diagnostics, logging, you can pop up this log facility. And you may be asked to do this if you're doing some of the beta testing. This gives us a chance to see what's going on under the hood as you are running the machine. So I'm going to enable the control, and we can see that it's leaving the idle state. We're swapping into running, setting up its modal state, and doing a bunch of various things, as well as all the enable lines. And we can see to the millisecond how everything's happened. This is a very powerful tool for us for the debugging side of it. And this is part of what's kind of held us up a little bit, is we wanted to have a good array of tools before we get started. I'll staple that to the top. This screen, though it looks like WXMach, is not WXMach. This screen is a real screen design screen. So some of the entities that we have now that we never had before are tabs. We can have multiple toolpaths on one page. We can have more tabs. You can have tabs within tabs. You now can have sliders for whatever you'd like to do. Just a lot of features we have, much like this blinking light. That is all done by the PLC script in the background. And we'll go over some of that stuff and how you would edit it. You can see I'm building a log file as I run. I'll stop this and clear it. But you may be asked to do this if you're in testing for us. To edit the screen, we can go under Operator, Edit Screen. The screen will go into an edit mode. So right here, you see everything kind of jump around. Now we're in edit mode. And this is the design size of the screen. Some of those basic features you can set here if you click on the name of the screen set, which is WXMach. The label is Mach4. You can see it says Mach4. And you can rename it whatever you like. So this is now Mach4 Brian's Mill. And now we see up here it's Mach4 Brian's Mill. We can change the design size from 1024/768 to whatever we'd like, and that'll change this black line so you know where all your entities are going to land on the screen. We have a refresh interval here, which is set to 50 milliseconds. This is how fast your DROs and toolpath will update. So if you have a little bit faster computer that can handle a little more graphic intensive stuff and handle the update speeds, you can increase this to get a little bit smoother looking DROs and toolpath. Here we have the PLC interval. This is what would be equivalent to the macro pump that we have in Mach 3 right now. There's a PLC script that gets called and it does a top down. The intent is at a later date we actually will be developing a PLC interface that writes Lua code so that if you're more comfortable programming in ladder logic, you actually will have that capability in here. This is the Events tab, so that was the properties. Here's the events for the screen. We have a screen load script, and right here you can see just a little bit of the script. We click on it, and this little button with 3 dots pops up. That allows the script editor to open. Now these are scripts that are running at load, so we have these global variables that are getting set to a value. We have a function, is access enabled access. It gets the instance, checks to see if the access is enabled, and then returns as a string to whether or not it is enabled. And then we have access enabled to enable an access or not. And we have a set property, button enable, label enable. This screen set property, anytime you see SCR means screen. Screen dot set property, and there is some property, some item out there of a name X position. It's a DRO, and it has a property called enabled, and we are going to enable that axis. So it's looking to see if axis 0 is enabled, and then chooses to set the X positive, X negative. I'm guessing actually those are probably buttons for the jogging. The 0 button on the multiple pages and the reference button on the very last page. So you'll notice depending on what axes are enabled, this gets called and sets them to be grayed out or not on the screen. And that's how that's done in this script. But this function is one we get to call everywhere because all these various chunks of Lua get compiled into one great big uh, scripting chunk in the background, and we'll show you a little bit of that. And by the way, this is MC Lua. This is Mach's Lua editor. So now we'll go into the PLC script, which is updating at 50 milliseconds. We set that under the properties. And this gets updated, and it's just top down, top down, top down. So this just gets updated every 50 milliseconds so that you can check to see what the state is, to enable or disable buttons, gray things out. And it's just us being a little bit fancy on this screen to show a little bit of the scripting interface. You don't have to do any of this stuff. You could just make the cycle start button available all the time. But if you look at the cycle start, feed, hold, and stop are grayed out. And the reason they're grayed out is because of this update script, or PLC script, I'm sorry. Here we have a signal script. The signal script is a really neat one. There's nothing equivalent to this in Mach 3. This is more of a notification of an event. We'll go in here and edit it. So this gets called, and when it gets called, it gets past something called SIG. This SIG can match up to MC dot. MC dot means Mach core dot, and these are some of the names that are inside the core, like OSIG is an output signal machine enabled. So if the machine is enabled, this would get called because SIG is equal to machine enabled. And then we get to do a machine enabled equals state, which is a global variable that we had set up in the screen load script. So if you wanted to say some of the output signals are soft limits enabled, all that other stuff, you can use that here and get that event and do something when it happens. So you don't have to poll for it in the PLC script. You can actually do it based on the changing of the signal when that event occurs. It's a pretty big difference because it uses a lot less CPU. It's just in a more efficient way of doing it. Now we'll get on to some of the less complex features that we have here. Let's say we wanted to move a button. We can click on buttons, and you can hold down the control key and use your arrow keys and bump them around with the control key held down. You can multi-select, and same thing with the control key, move multiples. You have all of the screen alignment tools for left, columns, tops, middles, bottoms, setting stuff the same height, moving them up, down, right, left, and setting spacings horizontal and vertically. So it's kind of a normal thing for screen editing, and you access everything through the menu structures, but you also have this bar here. Now let's say we wanted to change a feature on the DRO. For example, let's say we really want our AA-axis DRO background to become blue. We click on the DRO we're interested in. We could even find it in the tree right here. It's called ADRO1. And we come down to the BG color, background color, and this is the property. Remember earlier we saw some of the properties as enabled. So right here we could see that it was going after the enabled property and setting it to true or false to change whether or not this is grayed out or not. But if we would like to change this color, we could come up and set it to a blue. Press OK, and there we have a blue background. You can change the foreground color. You can underline things. There's just so many things. You can unbold it if you would like, make it a light. It's a little more elegant. You can change the style to slanted. We can justify it right, center, left. You can change the formatting like you could in Mach4. What the value is, so you can do a get property on a DRO and read its value out. You can say it's tied to a register, which the registers, we haven't gone over this. This kind of replaces some of the old Mach4 DRO type things. This is something we've just added into the software as we found we needed a way to get more data in. But you can get a lot of really interesting data out, and we'll be enhancing this as time goes on. For example, you can see how many commanded e-stops have been done, how many feed holds have been requested. You can see the extents for the path for the axes. You can see the jog increments and so on and so forth. You also can pick up registers that are user defined, so the user can define a block of memory to be some other value, and the DRO would take on that value from there on out. Whether it's not, it's hidden, it's Z order, and it could have a DRO code associated to it, and these are more of a hard-coded type thing. This really is the DROs of Mach4. This is more like the OEM DROs would be the registers. So these are Mach specific, and you can see we gave you quite a variety of them. Let me click off before I change that. And we also have events. So we have an update script as well as a modified script. So for an update to it or to modify it, you can change what they do by scripting them in. You can see we don't have anything. It's all automatically done. We have the same thing for events for buttons. We'll click on cycle start. We have a left down action. Anything that we deemed an action has some default functionality, built-in functionality, if you will. For example, if you want to turn toolpath jog follow on, turn it off, or toggle it, you can simply set this as an action and it will be done. We also have left down script, left up script, and a clicked script. So it's a confirmed click. So you can say down, up, and if we look at a jogging button, you'll see we did a down action of -1 jog, a up action of jog off. We could have done the same thing with a script. So if we wanted to preheat something, start it moving, turn the wire off, and shut the axis off, we could do that through a script. We can have a lost focus event on the script, and I believe, that hasn't been coded in yet, but there'll be a lost focus on the keyboard to disable keyboard jogging functions as well. Let's see. We have a go to page, so you can say go to a separate page. An interesting thing about this screen is completely done in one page, but if you wanted, you could add more pages inside of this by clicking on here and adding a page. So the screen designer is much more powerful, but it's completely built in and allows much more flexibility without loading any third-party software. Tabs, same thing. You can go to the notebook for it, check its properties, and if we go up a level, actually right here, you could add a page to the notebook and add another tab. I think probably the best thing to do is just kind of play around with this and have fun with it, but as you can see, it allows for some very complex things to be done in the background, but it also allows for very minor changes to be made without any programming knowledge. So here we'll say we're all done editing the screen. I'll say yes, we're happy with it, and here it comes up. I've got this nice pretty blue DRO, and if we want to see all the script that's running inside of the screen, we can go to operator Lua script, and here is a view of the Lua script that is running in the screen right now. And this kind of allows you to get a look at everything as it is compiled into one big Lua chunk. We also have the register files. This is another interesting thing that we can look at. And we were talking about registers earlier. We have some core registers that we're starting to add in. Example is the cycle start one. Let's slide this over and I'll press cycle start, and you can see I've pressed it 8 times, so we can see that we've had 8 requests to do it. If we had our logging window open, you'd see that it was trying to do a cycle start, but it couldn't transition into that event. There's a state machine running under Mach4, allowing it to get into certain states or not to start running code. It's kind of a big selector switch inside to figure out what it should be doing at that time. There's also the selection of motion devices. We can do some configurations on plugins. We'll get into more of that stuff as time goes on, but I just wanted to show the basic screen design utility, because there was a little bit of a kind of a false thing going on here where it thought that Mach4 wasn't as configurable as Mach3, and I think, hopefully after looking at this you can see that not only is it configurable, it's much more configurable. And as the last thing we do, we'll show another screen. We'll go load screen, and this screen, I believe I have a plasma screen loaded, plasma.set, and this plasma set is a very simplistic screen. It was me getting ready to build one, and in here there's our first wizard. We like to pick on hole pattern wizards, and you can see we have drop downs and whether or not what direction spindle we want, how many paths, the diameter, the center. We can post the G code, and we'll jump back up and call it test file, drill, not frill, but drill, and save it. It automatically loaded the file in, and it's ready to go. So we have added a Lua panel, which the wizards can be integrated in the screen and exchanged because it's a separate Lua chunk that you place in. And I'll just show that real quick. So as you can see, it's a blank panel. It's a Lua panel. It's right here on the board. And here is the script for it. It's much more complicated than the old ones, but we kind of figured that maybe the users aren't going to write these as much as we are. Anybody is welcome to do them. They're open source. We're doing ours as a BSD license, so anybody can edit it. And I tried to make some little wrapper functions to add an input control and so on and so forth. Here's where it gets the profile strings. This is the equivalent of grabbing it out of the INI file. So you tell it the INI name, and it grabs these out of the machine's INI file, so you get your last save settings. And here's where it does the G-code generation. And right here is where I am getting the output path and writing it, and I get the file dialog. So you're seeing a combination of WX, which means using the WX framework, and some MCs in here, which is to load the file into Mach4, and then to save all the settings. That's calling a function up here to save settings. And there's various things called sizers, and if you look, this MC Lua parent, this also can be run as its own window. So it's a fairly intelligent thing. We'll go to debug, just click run, and let me drag it over here, and you can see that it's its own window now. So you can post the G code, exit, and it takes on more of a window type format with the frame and everything, rather than being built into the screen. So as you can see, it's a bit different, but much more powerful, a little more complex, but in our experience, most people that are dealing with these wizards do have some programming experience, and if not, the source code is available, and feel free to take it, tweak it, play with it, have fun. We think it's a really interesting way to do it because it gives you more tools to make a more professional looking interface through these custom things that you might want to do with your machine. So we'll close that. That's our Lua panel. And we can go back to page 1 and look at that with all of its various features. And here's page 2. And the default screen is equivalent to screen 0 in Mach 3, where you can have whatever you want on that is persistent from screen to screen. So here we just have buttons that get us from page to page. And here I just did some tests. I got little things plunked all over the place, little buttons and stuff. Hopefully that is a good example of what we could do with the screen if we wanted to. This concludes our video of the Mach GUI screen designer and what executes it as well. And I hope you find it to be a fairly powerful interface. We will be going over it in a lot more detail later on, but I was trying to give you a quick view of it as we get ready to release it so that you'd feel comfortable to just play around and look at what's inside the screen. Thank you.